Dear students, welcoming you all for another session on circuit breakers. This video will discuss about oil circuit breakers. In the previous video, we were discussing about the classification of circuit breakers based on the medium used for quenching the arc. So here we will be using oil circuit breakers where oil is used as a medium for quenching the arc. So we know that the mineral oil which is used in transformers has better insulating properties than your normal air. It is also having good cooling property. In transformer we use mineral oil especially for insulation purpose as well as cooling the transformer windings. Similarly, the same mineral oil can be used for quenching the arc in circuit breakers. So when arc is formed, the mineral oil that is surrounding the contacts will decompose the oil into hydrogen gas. Like transformer, there will be a tank and which is filled with mineral oil, and in between them the moving and fixed contacts will be kept. Whenever the arc is struck, the arc will be surrounded by the oil, and the oil will be decomposed into hydrogen gas by using the arc energy. So the arc energy is converted into some other energy, and we all know that the hydrogen gas has a good cooling property, and hence the hydrogen gas cools the arc so that the arc will be quenched. And these circuit breakers are available in the voltage ranges from 3.3 kilovolt to 420 kilovolt. And this is the picture of a minimum oil circuit breaker. In oil circuit breaker there are two different types. One is bulk oil circuit breaker, which uses a huge number of a huge amount of oil for circuit breaking, and this is the second one, that is a minimum oil circuit breaker, which uses a small amount of oil for circuit breaking, which is advantageous than the bulk oil circuit breaker. When we see the construction, this minimum oil or low oil circuit breaker is having three different chambers separated physically and filled with oil. So first one is circuit breaking chamber. So this is the circuit breaking chamber, which consists of the contacts, fixed contact and moving contacts, and arc extinction device or arc control device. And the top chamber, this is the top chamber, which is used for accommodating the additional oil, that is expanded oil. It is used for providing the space for the expansion of oil. And the third one is supporting chamber, which is made of porcelain. In fact, the entire system is covered by porcelain material, and this is acting as a supporting structure for the circuit breaking chamber and the top chamber. And it is also having the operating rod and glass fiber enclosures. Let us discuss about the operation. So during no fault condition, both fixed and moving contacts will be closed and the current will be flowing normally. So whenever there is a fault, the fault will be sensed by the relay, and the control mechanism will pull the moving contact downwards inside this oil. Smoothly the contact will be coming down. Therefore we know that when the contacts are separated, the current is interrupted, and an arc will be struck between the fixed and moving contacts. Now this arc will be of high temperature, and that arc will be vaporizing the oil surrounding it. So the oil that is present in this area will be getting vaporized, and hydrogen gas will be produced at high pressure. So the oil is converted into hydrogen gas which is at high pressure. Now because the new gases are introduced, they will try to move from this point to the other, and hence there will be a turbulence of oil is created. That is, the oil started to move in round structure. So because of this, the arc energy will be converted into hydrogen gas, and the hydrogen has the better cooling property. The arc will be cooled, and hence the arc cannot exist. So the arc will be quenched at natural current 0. So this is how the minimum oil circuit breaker operates. This is the practical look of a minimum oil circuit breaker used in a substation. So three legs for three different phases, and inside this the fixed and moving contacts will be kept with oil. And you can see here this is the moving contact, and these are the fixed contacts. Between them an arc is struck, and the oil surrounding this space will be converted into hydrogen, and hence it cools the arc. Now let us discuss about maintenance of oil circuit breaker. So whenever the breaker interrupts the current, the contacts may be burnt by arcing. The arc, because of the heat produced in the arc, the contacts may get burnt. And the another problem is more frequently, if braking operation occurs, then there is possibility of the oil gets carbonized, and hence the oil will lose its dielectric strength. If the oil loses dielectric strength, then it cannot quench the arc, or it cannot provide in proper insulation. Hence the replacement of oil is frequently required, and also the replacement of fixed and moving contacts also required. And frequently the dielectric strength of the oil also needs to be checked, and the oil level also needs to be checked. So oil in good condition should withstand 40 kilovolt for 1 minute with 4 mm gap between the contacts. So even if the gap is 4 mm between the contacts, and if you apply 40 kilovolts voltage, then there should not be any arc produced. So in that case you can say that the oil is in good condition. And the main disadvantages, as we discussed, this oil is inflammable, and there is a possibility of fire hazard. And there are some byproducts produced whenever the oil whenever the circuit breaker uh, interrupts the arc. The carbon particles are produced, and they will further reduce the dielectric strength of the oil. Hence the oil circuit breakers are not suitable for interrupting heavy currents. They can be used for interrupting maybe low values of currents. Thank you. In the next video we will discuss about the sulfur hexafluoride circuit breakers. Thank you.